Hello everyone. We are going to be learning algorithms and analysis introduction. This is part of our day 3 learning, and let us have a brief understanding on what an algorithm means. So, algorithm is a series of instructions or step by step instructions to solve a specific problem. Let's say we can take an example. Let's say we have to cook a food, right? Or let's say we have to cook rice. So we wash our rice, then we ignite our stoves, gas stoves, or ovens if we are using oven, and we boil the rice. If we are using cooker, then we boil the rice for about 5 or 6 whistles, and then we open the lid after all the pressure is done, right? So these are set of instructions that we can think. So similarly, algorithm is also a series of instructions that we tell a computer to perform to solve a specific problem. And we can also see that a specific algorithm, a specific problem can be solved in multiple ways. Like we know that cooking rice can be done with microwave oven or even by a gas stove, right? So analysis or judging a specific algorithm goes by correctness, that is, whether it is performing the expected operation and giving us the expected result, and an efficiency factor where we say these are the set of resources that it is using, like for example, time and space, right? So, when we talk about analysis of an algorithm, we can say I will also write few things here just to have the board going. So algorithm as we defined, to solve a problem. Judging an algorithm is done by one, correctness, and two is done by efficiency, memory and time. Analysis of algorithm So, uh, analysis of algorithm. Before even we discussing on how we analyze an algorithm, let's take an example where we ask a group of people to perform a sorting operation, right? So there are multiple, as we know by now already. Before even coming to this session, we already know there are multiple sorting algorithms like an insertion sort, a bubble sort, a merge sort, or a radix sort, or a selection sort, or a quick sort, or there might be many, right? One might even have their own custom sort, right? So the implementation is something that might vary with all the folks, but how are we going to measure such algorithms performance with uh, other set of uh, code or other set of algorithms, right? So we cannot measure it by, let's say, lines of code, or let's say we cannot measure it by the time of execution by that a computer gives an output, because uh, there are computers which are a lot more powerful than the ones that you and me might be using, so it is not good to measure it that way. So and standard of measuring or analyzing algorithm will be with respect to time and space complexity, where we measure based on the input size, and we measure the rate of growth as the input size grows, and we say, let's say, uh, so we measure based on input size. Let's say, uh, we have an input of array. This might need to be iterated through each element, right? So this might take about in length of items. Similarly, let's say if we have a constant, a single value, let's say 18, single value. So this might take constant space of 1, right? So yeah, so this way we should have an idea on the times complexity. This might be t of 1 and o of n, we call it, right? And space complexity might also be varied based on the way the program is designed, right? So we measure based on the input size, and we see the rate of growth with respect to input, right? So this is how we analyze our algorithms, right? And so in the next chapter, we are going to understand a lot more into what this rate of growth and different types of analysis that we have, right? That's it for now. So hope you understood a brief definition on what is algorithm and how we judge it, and also a brief introduction on analysis of algorithm and how we analyze an algorithm, right? Hope you found this video helpful. Please do like and subscribe to my channel. Thank you.